Hello everyone, welcome to the Chemistry Box, your one-step chemistry guide. Today we are moving on to the second named reaction of our series, and that is benzoin condensation. So let's see what the reaction has in it. If we see in the reaction, we have two molecules of an aldehyde which does not contain any alpha hydrogen atom. What does that mean? Now, if this is our aldehyde group, the next carbon atom should not have any hydrogen. The next carbon atom is going to be our alpha carbon atom, and this carbon shouldn't have any hydrogen atom. Now, such a molecule, that means two molecules of such an aldehyde in presence of a nucleophile. Now, nucleophile we are going to use cyanide ion. This cyanide ion would be coming from KCN, and this cyanide ion is going to act as a catalyst over here. That means it is going to get regenerated at the end of the reaction. This cyanide ion is going to help convert these two molecules of an aldehyde into a benzoin. Now what is benzoin? Benzoin is alpha hydroxy ketone. That means the two molecules of an aldehyde get converted into a benzoin molecule, that is alpha hydroxy ketone. Now let's check out the mechanism behind this. Now in step 1, what we have is the attack of the nucleophile on the first molecule of an aldehyde. Now here we have the aldehyde. We have taken benzaldehyde as our example. So we have this benzaldehyde molecule, and here we have our nucleophile. Now this nucleophile is going to attack on this carbon. Why this carbon? Because this carbon is attached to an oxygen via a double bond. Now oxygen being more electronegative, it has a partial negative charge, and this one has a partial positive charge. Therefore, this CN is going to attack on this carbon atom. Always remember, we are going to show the arrows from the negative to the positive thing, right? Now, after this is going to attack on this carbon, the molecule that we get is now, if this nucleophile is going to attack on this carbon, one of the bond is going to move on to oxygen. So the pi bond has shifted on to oxygen, and now this oxygen is going to carry a negative charge like this. This hydrogen will be as it is over here, and there will be a CN attached to this carbon atom. So this is the molecule that we have got in our first step. Let's see what happens in the second step. In the second step, what we have is an intramolecular proton shift. What does that mean? That means a proton from the same molecule is going to shift to other position rather than from its own position. What we have here is this proton next to this oxygen. This oxygen with the negative charge is going to attack on this proton to accept the proton towards itself. In this way, what happens is these electrons are shifted onto the carbon atom now. What we get is a carbon ion out of it, where now this becomes an OH because the hydrogen gets shifted over there. Always show the arrows from the negative particle to the positive ones and the shift of electrons to the atoms. Now we have a negative charge on this carbon atom, and the cyanide group is as it is over here. Now, as we understand, here this carbon is attached to cyanide group. That means what? This negative charge of this carbon is very much stabilized because of the cyanide group, as the cyanide group is going to conduct resonance and share this negative charge in the molecule itself. So therefore, this carbanion is a very much stabilized carbanion. Next, move on to the next step. In the third step, what we have is attack of the carbanion. Now in the second step, the carbanion that was formed is now going to act as a new nucleophile over here. यहाँ पे जो कार्बानियन हमने लिया था, अब वो अटैक करने वाला है सेकेंड अल्डिहाइड मॉलिक्यूल पे. कैसे? लेट्स सी नाउ. यहाँ पे ये कार्बन एटम एक नेगेटिव चार्ज कैरी कर रहा है. जो अल्डिहाइड मॉलिक्यूल है उसमें ये कार्बन एंड ऑक्सीजन का जो बॉन्ड है दैट इज अ पोलर बॉन्ड. यहाँ पे हम देख सकते हैं इसके पास पार्शियल पॉजिटिव चार्ज है एंड दिस वन कैरीज अ पार्शियल नेगेटिव चार्ज. What will happen over here is this negatively charged carbon is now going to attack on this partially positive carbon. What happens is there is a new carbon-carbon bond formed between the two. What happens because of this? एक पाई बॉन्ड जो है वो चला जाएगा ऑक्सीजन के ऊपर एंड ऑक्सीजन के ऊपर आ जाएगा एक नेगेटिव चार्ज। सो व्हाट वी हैव इज ये वाला बेंजीन रिंग यहाँ पे है, द कार्बन एटम विच वॉज हियर कैरिंग OH ग्रुप एंड साइनाइड ग्रुप, वो मैंने यहाँ लिखा है। नेक्स्ट नाउ दिस कार्बन कम्स ओवर हियर, सो कार्बन कार्बन डायरेक्ट बॉन्डिंग फॉर्म हो गई है। द ऑक्सीजन विच वॉज हियर नाउ कैरीज अ नेगेटिव चार्ज एंड द नेक्स्ट molecule, I mean the next part of the molecule. So this is the thing that we get in the third step. अब इसके आगे इसके अंदर कैसे changes होंगे, let's see in the next step. Now in the last step what we have is intramolecular proton shift and removal of the nucleophile. So what we have here is this molecule that we got in the last step, that is third step. ना यहाँ पे हमने क्या किया है, CN को मैंने ऊपर लिख दिया है एंड जो OH है मैंने इसको अलग तरीके से लिखा है। What happens here is कि यहाँ पे जो ऑक्सीजन है जिसके ऊपर नेगेटिव चार्ज है, this is going to attack on this hydrogen for accepting the proton. Now in return this hydrogen is going to leave out the electrons to this oxygen and carbon bond and therefore this CN is going to go away. Now it is going to leave the molecule. So what we have here is the removal of the nucleophile, that is Cn minus. As I told you, it is the catalyst and therefore it is going to leave the molecule and get regenerated at the end of the reaction. So it is going away now. What happens now? यहाँ पे जो molecule का rearrangement है, that comes to this. The first part of the molecule, the benzene ring. यहाँ पे what we have is this C double bond O, so we have got our carbonyl group. On this carbon we have OH group now, as this oxygen has accepted a proton from here, and on this carbon we also have the other benzene ring. Right? Now यहाँ पे हमारा जो कंपाउंड है वो रेडी हो गया है, that is this is a alpha hydroxy ketone which is also called the benzoin. In this step the final product, that is benzoin, is formed. The two molecules of aldehyde combine together and give you the final product benzoin. You can also have cross benzoin condensation, in which both the aldehydes that you are going to take, both the molecules that you are going to take will be of different aldehyde. That means you can take a benzaldehyde and a formaldehyde molecule, right? In a similar way, you can also add different aldehydes which do not contain any kind of alpha hydrogen atoms and then condense them to form the benzoin compound. I hope the benzoin condensation is clear to all of you. If you have any more doubts, please post them in the comments below. If you like this video, please hit the like button. If you like our content, consider subscribing to the channel. Till I see you in the next video. Bye bye.